guys, so here we are for the AutoLISP script that I created for HVAC duct design. Let's just load it. Now the shortcut is SM. We are going with CFM. Select mouse. It's a CFM. The input size is mm. We are going with friction loss method in imperial. The dimension is in mm. We are setting CFM to 1000 and then the friction will be 0.1 inch. The preferred duct height, I would say 300 mm will be okay. Let's select the starting point here. So you can see we are getting width automatically here. Also the text is also added here with the duct, so we don't have to add it manually. Now let's say we are going to bend it. We say bend 90-degree bend we want. Let's say right side, and the right side is downward, left side is upward. Let's say 0.5 inch, 0.5 into width, and here. Now we are going straight again. See, now let's say we want to reduce the duct size. We take reducer, and we select CFM is 600, and with the preferred height I would say 250 mm. The calculated size is 275, but we can go with rounded 300. Let's say this. So this is now asking for reducer length, that is, let's say 600 mm. Okay, now again let's change the width and the height that is selected, and also the CFM that is selected. Now let's say we measure it. See, it's accurate 300 mm. Also let's just use it in inch. Now let's say again we are using shortcut SM for shortcut. We using CFMs in input out in inch, and let's say we are going with velocity method, that is time, FPM, and gain inch. Now let's select 1000 CFM, FPM will be 1000, and duct height should be again same 300. Oh, sorry, 300 was in mm. Let's just do that again with SM shortcut, CFM in inch, let's say velocity method, in FPM again inch. Again we are going to add CFM 1000 CFM, and FPM will be 1000 again, and the preferred duct height should be let's say 250, it is 10 inch. Now this, see, 1000 CFM duct height should be 10 inch, that is 250 mm, and then 14 inch. Let's see what is it we are getting in macro duct size. Let's say 1000 CFM, we are going with velocity, and again 1000 CFM. So we are getting this. This is 10 by 20, the 10 by 14. Let's see metric, the 350 by 275. That is nearby correct, but it is okay. That's how the duct design should be. So again we can go with these bands, and the same thing continues with the same method. Okay, I will be adding more of things like shoe piece, and then we can select the reducer type like eccentric or eccentric, whatever we want. Also, I will be adding like Y and T's are all in this later. Just I will be adding that, like it will take time to make that script. Just connect with me, or you can put a comment below so that I can understand what do you want, really want. I think it is pretty time saving. Sometimes, let's say in normal duct design, we say we have to, let's say this is center line, then go with like this. Let's say IPS unit 1000, we have to put it 1000 CFM. The velocity should be, let's say we want 1200. Then we got the size. Okay, 14 by 9. We can move ahead with to 8. So this is it. So 350 by 8. That's after that 350 is equal to 175. I have to offset both side. This and this. Then we go here. Then put this and also offset 350. Then let's see fillet. We want radius of 150. Then here and here, then I have to offset this as well, 350 this, then we have to trim this. That's so much of time taking. We know that we have to also put this and this. See, this is so much time taking. Now also this doesn't have, we have to put it manually. Every time we have to change it, type it, edit it. So see you guys in next video. Thanks for watching.